Let me tell you a little about myself. About 5 years ago, I switched careers. Before that, oh, there's something weird with the screen there. No, it's good. Okay. Before switching careers, I performed a lot. I taught a lot. I got my master's degree in piano performance and pedagogy. Pedagogy is a fancy word for teaching. So I taught university classes. I taught music majors piano lessons. I taught piano lessons from my home. So my youngest students are like 6 or 7. My oldest student has been 70. So all ages and all kinds of backgrounds. So one thing that I always notice is teaching people the fundamentals. So like any complex task, if you can't really master the fundamentals, it's hard to go anywhere. So a typical scenario would be I have an 8-year-old student come week after week and he doesn't know his note names. He can't identify notes from the page and find a key on the piano to identify it. So the solution to this usually is assign flashcards. So I select a small deck of flashcards and send them home with him. If he practices them at all, he'll come back and probably forgotten half of them, lost them. So I have to scrounge around and find some flashcards. So my next solution is let's find some app on my phone. And I could never find anything that fit my needs. There's lots out there, but I wanted something that ran on my desktop, ran on my phone, ran on iPhone, ran on Android. Like, there's a lot of one-off applications, but I couldn't really find anything that met my needs. And then what if I want to go beyond just note names? I want to drill other things. So that's what I'll get into today. But the first task I want to do is let's just see if we can build just notes. Can we just drill flashcards? I was relatively new to Elm with the release of Elm 19. I thought, oh, let's go for it. I saw the Elm type system, and I thought this would be great. I can represent all this music stuff in types. So all the stuff I'm showing you today, it's not necessarily new. There's libraries in Python or JavaScript that do the same thing, but they use strings and a lot of parsing to represent all these things that just elegantly in Elm I can represent in types. So let's start off with our first type of note name. Now notes go from A through G, and by convention we start at C. So for some reason, because everybody knows middle C or something, we always just start at C. Now I have a demo today that I'm going to be using throughout. I have a keyboard, and I built a small Elm app that uses a lot of all the libraries and tooling that I built up to talk about this stuff. So here it is. We have, so for example, there's middle C. Let me show the note names here. C, there we go. So C, D, E, F, G, then it wraps it back around, A, B, and then we get back to C. So the next step is render notes. I won't get into this because it's like a whole nother talk together. It's how to lay out music nicely on the page. Well, let's just say I have this magic function that I also wrote in Elm that I pass in a list of notes because we might want to in the future like display more than just one note, which we will, and spit out some nice SVG. So here's my first prototype. I can drill notes. Now this is only useful if I'm sitting there with the kid in piano lessons. I bring this up on my phone and I drill them. I can give them feedback. So my next step was, can I build like a full application, kind of like Duolingo or something, that would give them immediate feedback and they could kind of track their progress. So that's my next step here. And I'll give out the magic link to this at the end of the conference. It's up and live, and you can all play with it. So let's first go to note names. And let's drill treble notes C, D, and E. Great. So we can drill them. I just randomly generate these notes and then draw them onto the staff. And maybe get it wrong. And after last talk, I've probably considered how inaccessible some of this stuff is. These are buttons, though, so I think it would pass that test. Okay, so that was pretty good. Like I said, this was my first thing of any complexity in Elm, and I felt very encouraged by that. So I thought, wow, let's take it further. Let me provide some motivation for it, though. So if we draw the analogy like music is like chess, just being able to name the chess pieces by no means makes you an expert chess player. There's all these relationships between the pieces. When you move one piece, it impacts the whole play of the game. Take a minute, look at this board. I'm going to give you like 10 seconds. I want you to memorize it. This is an actual chess game. This came from an actual game. All right, so now I hand you a blank board and a box of pieces. Now place all those pieces on the board. How well do you think you'd do? If you're a chess grandmaster, you'd do a lot better. If you were a novice like me, you'd probably do pretty horrible. So in the 70s, some researchers studied this, actually, and I find it very interesting, and especially as a musician, I found this very interesting. So this top blue line here is the more experienced the player, the better the player, and they have chess rankings, so the far right is these grandmasters. The better the player, the more accurately they were able to place the pieces back on the board. So you can see if you were a grandmaster, you'd get like 12 pieces back on the board. And if you were a novice, you might get, a couple, the corners maybe. On the flip side, what's really interesting is that they showed all the participants of the study random boards that weren't from any game. The grandmasters did just as well as, or as poorly, as the novices. They maybe got a couple. So what this tells me is that like the grandmasters, they will see relationships between the pieces. So I'm not so much interested in like just raw memory for memory's sake, but there's an interconnection between memory and understanding of the thing. So when you move a pawn, that has some meaning. When a grandmaster looked at that chessboard, there was some meaning. There were relationships between all those pieces. Likewise, if I hand you a piece of music like this is Franck's Violin Sonata. Most people, you're probably just going to see a bunch of random dots on the page. But when I look at this piece, or some other trained musician, I see all these patterns. I see scales, I see chords, I see phrases, I see how the top violin part relates to the piano. I see all these patterns, I hear them, I see them on the page. That's where I want to get my students to. It's more than just naming notes. We've got to help them see the relationships between the notes. So this is the realm that we would call music theory, is how do we describe how all these things interrelate? So the most basic concept, let's start with intervals. So an interval is the distance between two notes. So let's just take letter names. Say we take a C and we have a C and a D. We would call this a second. Or a C and an E. We call that a third, and fourth, fifth, sixth, seventh, and so on. So if we map these to an integer, we can now compute some kind of distance. So I pass in the note name, either A through G or C through B, and map that to an integer. And now we can compute distance. Now with my first naive approach, there is a problem with this. What about the octave? So what do I mean by this? I mean, on the piano keyboard, let's take this down. The patterns are self-repeating. So we go C, back to C again. So my first approach, back here, if I did the difference between C and C, we would just get 0. And if you look at a real piano keyboard, there's like 7 C's on the keyboard. So we need a more sophisticated model for what it means to be a note. So let's create a note record. It has the note name, and it has an octave. And the way we specify octave, like the first C on the piano would be C0, C2, C3, C4, and what we would call middle C would be C4, be the fourth piano, C5, and so on. Now we have a new distance function. We pass in the note, and now we need to take into account this octave. So we get the integer representation of the note name, and then we add to that this offset. So there are 7 letters, A through G, and then we multiply that by the octave we're in. So C4 would be 7 times 4 plus 0, and take the distance. Now we need to do the flip side. The math is basically the same. It's a little more complicated, so I'm not going to show it. But I need to be able to generate these things. So if I give you a note and an interval, say I give you a C, like middle C, and say give me a third above that, then this function would return E. And we'd use it like this. Middle C, interval, return me E. Again, I made a crude demo, and initially I used this with my students, and I could kind of select whatever I wanted down at the bottom. But similarly, I want a way to drill that on my students, so let's go to basic intervals. Let's go back here. Let's just do it on the staff. So this is the same. Yeah, you get the idea. I have another way to draw, so I can provide a new render function to a piano keyboard. And I can drill the same kinds of things. So I have a mapping between what it means to draw things on a keyboard and on a staff. This is a little easier. You can just count up 1, 2, or 1, 2, 3, or let's get it wrong. Oh, and it gives me, which is not accessible, probably, especially if you're colorblind. But I'll fix that. I'm not sure how, but we'll fix it. Okay, so we have intervals. Now I'm kind of lying to you. My way of thinking about intervals is very simple. What about the black keys on the piano keyboard? So what do I mean by, what I mean is, if I have C to E, that's a third. But the C to this E is also a third. Are they the same third? They're not exactly. We call that thing quality. So we have the quality, what type of a third it is. So we would call this thing a major third. Usually people think that is happy. And a minor third, or sad. So how do we represent this? So we have an accidental, and that's what you see as the, there you go, the little b is a flat. So what I tell my little piano students is that when your bike tire goes flat, it goes down. And when we have a sharp, if you get poked by something sharp, you go up. Oh, let me do the sharp. So D sharp. Now the curious thing here is we have to have some way to think about this a little better, because an E flat here is the same as a D sharp. So we can't just use another, we just can't leverage what we've already done with letter names, because it's a little more sophisticated than that. Furthermore, if you look at the piano keyboard, it's a little wonky. Between E and C here, there's no black key. And between B and C here, there's no black key. So we really do need another representation of this keyboard so that we can figure out the quality of this interval. So let's come back. If we have a C and an E, that's a major third, we will take the absolute key count, what we would call half steps, 1, 2, 3, 4. So these two pieces of information, the letter distance, which we've already done to be a third, and this absolute count of keys, which in this case is 4 half steps. So these two pieces of information describe what it means to be a major third. And likewise, an E, a C to an E flat is only 3 half steps. 1, 2, 3. So we can further fill out our note record. We have a note, name, we have an accidental, one of sharp, flat, or none. There are others I'm hiding from you. If you're curious, you can go read about it. And an octave, so which one on the keyboard are you specifying? And I can drill that too. You can poke around on the app and find that. You can just drill sharps and flats and find them on the piano keyboard. So now we can compute interval quality. Major and minor. So we need a way of mapping our notes, the letter name, to a new representation. So C is 0, D is 2 because there's a black key. And if you look at E and F, there's no space in between, so just 4 to 5. And then it's kind of hard to see, but B back to C is actually no step because there's 12 unique keys on the piano keyboard. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We need a way of mapping our accidental so that we can shift it where we need to. We need a way of representing that note record as in half-step count. So like our C, say we take a C sharp 4, so middle C up 1, we would take 0 plus the accidental plus shift it by the octave again. So notice here it's not by 7, it's by 12 because there's 12 unique keys on the keyboard. And likewise, we can keep going here just like our other function. Now we just need these 2 pieces of information. We have the half-step count and the letter distance count. And these 2 pieces of information will give us exactly what this is. And since this is base 0, to report the interval, I need to add 1 to it. So I hate doing case statements on integers. So this probably should return a maybe. So third, if you are a third, so like between C and E, and you have half steps of 3, then you're minor. If you're 4, major. And I would just need to provide all the cases. Now, this is my first naive implementation. What about a 10th? So what do I mean by that? Oops. So if we go, it repeats. Turns out the quality is also a repeating pattern. So this third here between C and E is a major third. If we take this C and E here, it's also a major 10th. So 10 minus 3. So it's really just some mod arithmetic. So I don't have to explicitly state if I take any 2 piano keyboard keys, like the lowest and the top. Under my previous implementation, I had to think about doing all of them. But since the pattern's repeating, I can just do some modular arithmetic. So just like before, take the letter distance, but now it's mod 7. So treat that 10th, C to an octave above, and treat it as if, so take this here, treat that as if it were just this. And then count the half steps to find the quality. And then return your original letter distance, so the 10th. And just like before, we actually want to generate these. The math is pretty much the same, it's just kind of inverted. So given a note, like middle C, and the quality in an interval, in reality I'd probably use some like a type here as to pass in, and return me a new note. So something like this. Given middle C, with no sharps or flats, and the interval minor third, return me the thing, so E flat. Again, here's my prototype, and let's go to the app now. More intervals. Yeah, so some of these look kind of scary, but let's see if I get it right. There we go. And again, we can do it on the piano keyboard. This will be a little easier for you to see because all we have to do is count the half steps We don't even know what this thing is. A minor second up. Well, I know a minor second has so many half steps. Just one. I get it. On the flip side, we can also do something interesting. We can provide an analysis of this thing by sending it back through the function. So if I take a C and an E, I can now compute. I can say, hey, this is a major third, this is a minor third, or an augmented fifth, or a minor sixth, or whatever, right? I can go backwards. Okay, what about other things in theory? So everything else is just built and composed of these smaller intervals. So a triad would be 3 notes. How do we define like this C major triad or a C minor triad? Well, it's just, if you look at this C minor triad, it's just composed of 2 intervals, here and here. We got a third here and a fifth here, and they have specific qualities to them. So given a note and a quality, so say middle C and minor, give me a list of notes that I can now render. I can pass this list of notes to my render function. Now I can generate that. Right here, minor and major triads on the staff. And a to-do item is to have students spell them out on the piano keyboard. And let's get it wrong. Okay? So what's next? After I built all this, we might want to do some harmonic analysis. So what does it mean for the relationship between 2 chords, 2 triads? So say a C major chord and an F major chord. Maybe we could generate music. So we could generate maybe jazz improvisation lines over the context of some harmony. Since we know what these things are, we can abstractly maybe define what it means to be a melody and generate those over a harmony. What about a back end? We could develop some similar system and type safely, store some of this information in the back end, so using Rust or Haskell. So you can find the app at app.knowyourtheory.com. So you can find it on your phone or on your desktop. It should work for all devices. If it doesn't, please contact me. So you can find me on most social media outlets at Pianoman Frazier, so on Twitter, on GitHub. I blog occasionally on pianomanfrazier.com, and that's pretty much it. Thank you.